If you want to automate video production today, the default path is to pay for a massive commercial platform. But by using off-the-shelf APIs, a developer can now shatter that monolith and replicate the entire pipeline locally for pennies. Tools like InVideo or Pictory have dominated this space. They offer an easy interface, but it comes at the cost of steep, recurring monthly premiums that eat heavily into a creator's operating budget. Worse than the price tag is the technical wall. These platforms operate as complete black boxes. If you want to swap out the AI writing the script for a different language model or adjust the timing logic of the voiceover, you can't. You are locked into their decisions. The financial drain is annoying, sure, but the true tax of commercial software is surrendering total control over your production architecture. Over in the open source community, engineers are solving this lock-in problem by building their own production lines from scratch. A developer named Chenwer727 recently published a project called the AI Short Video Engine. It has been quietly gaining traction on GitHub, currently sitting at 174 stars and 67 forks. Its core function is highly specific. You feed it a standard article URL, and it autonomously reads the text, writes a script, and renders a fully produced, viral-ready video reel. The engine utilizes a Streamlit interface, allowing the entire logic, from scraping to rendering, to execute on your local hardware rather than a remote server. Moving the production line inside your own firewall removes the usage caps, data privacy concerns, and subscription dependencies inherent to renting a commercial platform. The engine acts as a manager coordinating 5 tools. First, FastAPI scrapes text. That text goes to DeepSeek to generate a script. Next, Tongyi generates the audio track, while a parallel process pulls pixels footage. Finally, FFmpeg stitches everything into an MP4 file. By decoupling the architecture into these discrete steps, a developer can easily swap out Tongyi for an entirely different voice model or plug in a new video source without breaking the rest of the machine. Digging past the main workflow, the codebase reveals a few specific design choices that show it was built for serious production volume. For instance, the repository supports Cosyvoice TTS. This sidesteps the stiff, robotic delivery we normally associate with automated voiceovers by generating incredibly natural, human-like pacing and intonation. This diagram outlines how the engine manages its operations. Instead of keeping everything in volatile memory, it uses a lightweight SQLite database to permanently track tasks and manage rendering queues. Because states are safely stored in a database, a developer can deploy multiple instances of the application to process dozens of video requests simultaneously. The database architecture allows the system to scale from a single task script into a persistent, high-throughput video factory running on a local server. However, maintaining your own factory comes with distinct vulnerabilities. Your local orchestrator is only as reliable as the external tools it calls. The engine is entirely dependent on third-party APIs for its heavy lifting. If DeepSeek servers experience an outage, or Tongyi alters its pricing tier, your entire local pipeline stops dead in its tracks. Users are also running into functional gaps. Community issue number 3 points out that the tool only pulls generic stock footage, completely ignoring the highly relevant original images sitting right inside the scraped article. And the user experience for non-developers is still incredibly raw. As issue number 5 highlights, when a render finishes, the web interface doesn't even show you the output link. You have to go hunting through the back-end console logs just to find your video. The trade-off for completely escaping SaaS subscriptions and owning your architecture is inheriting the permanent burden of debugging, patching, and polishing the user experience yourself. Still, looking at the wider trajectory of software development right now, these are minor friction points in a much larger trend. We are rapidly approaching a moment where spending an afternoon deploying a custom open-source orchestration tool takes less time and effort than arguing with an enterprise procurement department to win a commercial license. If breaking down this architecture saved you a few hours of research, hit subscribe. We'll be looking at auto-swarm agents and multi-node processing in the next breakdown. My render just finished compiling, so I'm going to review the logs. Catch you next time.